Welcome everyone to this third and final installment of our webinar series with regards to using linked data solutions for your systems engineering solutions like your asset management, and today we'll be discussing things with regards to specification management. And let's start the presentation. So specification libraries for standards, or making the transition from text-based to model-based working. So myself, if you haven't been part of the previous webinar, I'm Stuart Edelenbos, business consultant at Semtech for the past 5 years or so, and my role within Semtech is also that I'm a library management specialist, which is one of the reasons why I get to present this particular webinar. In case Semtech is also new for you, besides my face, these are just a handful of clients with whom we work with. So we do solutions with regards to systems engineering or model-based systems engineering, and as well as solutions within linked data in order to benefit asset management and information management across these different sectors. Now, without further ado, what do we have in store for you today? Well, of course, we'll have an introduction as usual, which I'm more or less already doing right now. I will discuss some of the issues with regards to working with documents and working as particular in text-based documents. I'll briefly discuss what the causes are for these issues, and these are the causes that we've identified with regards to these issues, and the solutions that we have for these same causes, which it will be a specification library, but I will explain what that exactly is and where the benefits lie. And I will also present a small demo with regards to LACES, our specifications library tool. So the introduction. So a quick recap of the first webinar in our series was about linked data more in general, that we can use linked data to connect and share various data sets, and that you can access these data sets from your applications, so you can see what is published and use that published information. Then we had the second webinar with regards to object type libraries, how to what these are and how to use these for your asset management. How to standardize your asset data in order to create a cohesion across your application landscape, as well as how to communicate better and sharing your information better between asset owner and contractors, for example. And today we will discuss the specification management issues as well, because we have a linked data solution for this topic as well. So we'll cover common issues with regards to specification management. We'll talk about a transition from text-based to model-based management, and about publishing these requirements in linked data. So without further ado, issues working with documents and text-based issues, or with regards to specifications. Also, just a small disclaimer, I'll tend to use the term specifications a lot during this presentation. Of course, as we know as well, that some people tend to refer to requirements instead of specifications, or define these as two different separate entities entirely. Also, when I talk about specifications within this particular presentation, I could also be talking about norms or industry standards, ISO standards, quality management standards put in within a particular company, measures that have to be put into place for health and safety regulations, etc., etc. Virtually anything which tells us, which prescribes us to what we have to comply to in order to properly do or create something, is basically what I'll be covering this presentation with the term specification. Now, having that out of the way, let's talk about the issues at hand. So the first issue that we have with regards to specification management is that specifications are usually stored within text-based documents, right? So we have a document, and if we read into this document, we can find various examples of texts telling us to what particular objects or activities or functions, etc., what they should comply to, particular values of aspects that they should have, whether or not they should be limited to a particular speed, if there are functions which they need to fulfill, in particular, how to verify these specifications, these requirements that we set out for our objects or for our subjects in general. And it's not just these things that we find in our documents, which can be contracts or norms or standards, etc. But we can also find particular information with regards to what these specifications are about, right? So if you have a piece of text, it'll contain information about physical objects, the activities, etc. themselves as well, besides just the requirements. Now, we can usually interpret these and understand what is meant by these strings of text. And this is why often you find that if we have to use these texts within an engineering scenario or a project management scenario, that the documents are given to a person to read who can then identify, or is up to that person to identify, those various information entities stored within the text. Now, of course, this might not always be as clear-cut to the reader at hand, right? Is text A really a specification? They use a particular term to refer to a particular physical object, for example, an aeroplane or an aircraft in one text, and then call it specifically a Boeing 747 in another document. It can also be therefore be quite a difficult task for these readers of these specifications to try to extract this information from the documents. But say they've managed to do so, then it's usually up to these users, so these people, to then, once extracted, to put these bits of text, this information, into a particular format they can then use within their applications for their project, right? So one particular 3D drawing program, for example, might need the texts or the specifications to be written in an Excel format. The other might prefer an XML format to input the information in. Other times they have to be typed in by hand, etc., etc. Now, this is a very long and trivial task filled with risks and is very error sensitive. But it's usually not just one document that our users have to search through and have to identify information in, but various documents. And it's often not just once in one project, for example, or one phase of a project that they have to do this, but various times over. So you can imagine this is a repetitive issue, usually with the same set of documents, same set of information. You have to redo this every time over and over again, with all the risks and errors that might be part of this process. So that's one issue that we find is the extracting of the information from your text-based documents into something usable within your application landscape or usable within your project context. Now, of course, some bits in technology have smoothened out some of these processes, right? So we can do a search function, for example, for particular terms in the text-based document to help us find relevant information that we might want to extract and transform into something that we can use. But sadly enough, our human language, how great and complicated it can be in certain settings, isn't necessarily the best when it comes to extracting information and specific information that we want to use within applications or within projects. Take, for example, these simple examples with regards to bridges, right? So we can have bridge as a homonym, as it's called, so a word spelled and spoken the same but can mean different things, as a verb or as a noun in this case. You can have in the text perhaps references to people who have bridges as a surname, or instead of the term bridges being used, we have to look for other terms which might still encompass bridges which we want to say or know something about. So even if we were to create a drawbridge, for example, from these texts, if we were to use something like a search function or just read it manually, we can't be quite sure on the spot of what is and what isn't relevant to our, in this case, drawbridge. So human language is fallible. That's more or less just an extra point on the issue list. Next is the structure in which these documents, right, because we're talking about documents, texts in document format, is that they tend to be constructed within a chapter or paragraph form. Now, this structure is usually fine for us, right? It encompasses, sorry, it usually revolves around a particular subject and is separated and then easy to use for us to find particular topics that we're looking for. However, if you take a look at these examples, information can then be spread out because they might the topicization that they've chosen, so the discriminators is to now this information goes into this chapter and that paragraph or that subparagraph, might not suit our needs. So if we're looking for something about concrete pillars, to be specific, we have to scroll and look through different chapters and subchapters in the hope to find something relevant for us. The same if we want to find requirements dealing with the making of concrete pillars. So there are also healthy and safety issues that are stored somewhere in a completely different chapter in this particular example. So we have to scan an entire document to find information spread out all over the place, and then have to make our own interpretations whether or not these are relevant to one and the same subject. So again, document and text-based structures aren't really suitable or aren't very productive in terms of how we want to use this information stored within these texts and stored within these documents. Another issue is the issue of versioning, right? So usually these documents are produced in versions, and then it's a version of the entire document. So the entire set of information is published over and over again into new versions. However, it's not always clear what the changes are between the two versions or other versions. Of course, usually a changelog or something similar will be provided by those who manage and create the document, but even then it's not necessarily clear what has changed for particular subjects, right? It's usually, oh, these bits of text have changed, but not so much as these bits of information regarding bridges or aeroplanes or cockpits. These have changed, and this is the impact of those changes. So that's not always quite clear to us, especially if you're an end user, so you have to use, extract and apply this information. Say you've started with version 1 and now you have to comply to version 1.1. You've extracted particular sets of information before in your version, in your first version, but now there's some bits and pieces have changed. The question that leaves the end user, of course, is in what way are these changes truly impactful for what I want to achieve? Is this just a switch of spelling? Is this a switch of synonyms? Or have particular terminologies really vastly changed? For example, that you can imagine that an aircraft is a more generic term than an aeroplane. But does this have a big impact on what we were initially using this information for? Again, this is open to interpretation, and this interpretation is then laid at the end user, which you can imagine can result in errors and risks that you might want to avoid. Finally, one of the other issues we find with text-based, document-based working has to do yet again with this interpretation issue. So say we have a bit of text here extracted from a document, but now we want to apply this into two different applications or two different users or two different phases within the same project, but we have to comply to the same document. Now, you can imagine that users from those different phases or disciplines or what have you might have interpreted the text differently to suit their needs. Now, I'm representing this in simply in text, so you can imagine that that might be a rewritten or an interpretation done explicitly or literally on the text, or it might have been a smart analysis. But you can also just imagine that, for example, elements in the original text, such as aeroplane, might be called plane within the one program or one setting, and aircraft in yet another setting. And so these interpretations have, so there are different interpretations in the two different applications. Now, if things have been interpreted differently, or have been written down differently, or have been transformed differently from the source text because it has to suit those particular needs, you can imagine if we want to exchange data between these two data sets, because, for example, the one is a drawing program and the other one is an execution program, and there's an overlap in the information, and we want to share and validate and verify particular information, then it's important, it's key that we talk about, or at least know that we're talking about the same thing. But because we've interpreted the source text slightly differently and applied this slightly differently, this becomes, well, not necessarily impossible, but a very challenging issue to do. So yet again, text-based working is very fallible and perhaps even dangerous to use. So if we were to summarize these issues, what really causes these issues? Well, one of the causes is that the data is unintelligent. So this is really comes down to the information that we intend to use is structured, is stored in text, which means it's not necessarily or the bits of information that we want are stored in text, but this isn't computer interpretable. This is only human interpretable, and then also requires humans to make the transformations so that the computer programs for which this information eventually is intended for as well can make sense of it. So it's also up to these users to then structure this information in a particular way that the computer can use, but the source document is still unintelligible. The next step is that the data is disconnected. So for example, we have our original text document which says something about an airplane, and we have two different applications or two different settings or groups, disciplines who want to say, who have to say something about that same topic, about that same airplane. Now, because we have to abide to particular norms, specifications, and whatnot stored in this one document, it's important that this information is one way or another transformed into these applications. But as we've discussed, here we have the transformation or interpretation issue, that the text can be, or what the information that's stored in the text can be transformed in a way that's not uniform across the different applications, as well as how it's structured in these two applications, making it virtually impossible, or at least very difficult, to have sort of a uniform understanding about what we're talking about from an applicational sense, or even later if we want to transfer this information to one another, which makes it difficult to exchange. So firstly, the text-based information is stored, well, in text, and can be literally in paper, or could be in sort of replacements of this paper in digital formats like a PDF or a Word document, or perhaps even slightly structured in a way such as an XML document. But regardless, it's still text-based and still requires human interpretation as to how to best extract that information to the applications. And if we want to exchange the information between applications or between disciplines, etc., we come to difficulty because of the interpretation issues, or the two causes that we've discussed just now. If it's difficult between disciplines or applications within one organization, just imagine it can be the same or even a bigger issue if it's between two different organizations or parties, for example, our asset owner and contractor from the previous webinar. Now, of course, how do we see our solution? Well, again, we flip it around. We try to make the data intelligent, connected, and easy to exchange. We make it intelligent by extracting the information not into our computers directly, but to instead store this information and structure it in an information model, which makes more sense and is structured in a way that the interpretation, chances of interpretation are taken away. We make the data connected by ensuring that various applications or various usages at least have a common understanding, because we one way or another use the same information model as a source, that we all know what different bits are, so we have no misinterpretation as to what a particular set of information means. We make it easy to exchange by also publishing or storing this information conform particular standards. So this in practice looks more or less like this, that we store the specification information available in a published linked data platform, like our latest platform, which we'll discuss later on, which then makes it possible for various applications and various users to access the same standard set of information in an information model way, and it's also interpretable or readable, machine readable, because we use open standard formats such as RDF. Now, what are specification libraries then exactly? Well, a specification library is a set of standardized specifications which are intended to be reused by different users, different projects, etc., captured in an information model, made available to users by having it published in an open standard. This seems a bit clear-cut, but let me try and explain this even further. So again, we have our document with text, and in this text there's information. So as I said, we can identify particular sets of information in these texts, in these requirements. We can identify, for example, right, there's something like a physical object like an airplane. There's the two requirements themselves to which we have to comply to. There's something for a safe operation, so perhaps it's a function or something that we can extract from this information as well as apparently references to other documents and aspects of takeoff speeds. And because we know that these two texts are about an airplane, for example, we can then structure these by relating them to one another, creating an information model which makes sense, from which we can also pinpoint from one information object to another and how these are related. Let me explain that perhaps a bit further. So first we have a document for which we could, for example, extract something as a specification. Maybe there's also a physical object we can extract from this. Perhaps there's some more information we can extract from this document as well. Now, if we can do this by hand, but of course technology goes as it goes, so we could also perhaps automate this process of recognizing text and different information objects within the text, for example, by applying something as text mining or what have you, just to smooth and quicken up the process. And we can then link these bits of information together. Perhaps there's information we can link explicitly, perhaps there's information we can link implicitly, perhaps there's more information that we would like to add, which might not necessarily be in the document, but still relevant to the information that we've extracted from the document, for example, a means of verification. And then in this way, we've structured our information in a way that we don't have to interpret the text anymore, because we've made very clear that said text or said string is a physical object, is a specification, is an objective, etc. Now, once we have our information model, our extracted information model, we can then publish this in a linked data format in our specification library, which then makes it available for different applications to query or to import or to copy, what have you, the particular information required and necessary for those applications. They don't have to necessarily import the same, exactly the same set of information, because it might not be relevant to them. So at least they can more or less cherry pick what they need from the publication. Now, as we've discussed already in the previous two webinars, that the benefit, or one of the most important benefits of using linked data publications, is that you can link it to yet other publications as well. So even though we're now talking about specification library, you can also just imagine that the specification library is just another form of an information, a data library published in linked data, which means we can link it to yet other collections of data also stored or published in linked data, such as our object type libraries from previous webinar. And because these are linked together, our applications which are have access to, in this case, our SPL, our specification library, they can now also add relevant information, if there is that, from these two other publications into their applications, creating a more enriched set of information. Now, one more time, in case you've missed the previous two webinars or forgotten what linked data is exactly, linked data is a way of how to structure data in an open format, and which also allows you to share your information, which has the benefit that you can enrich it because you can add information from another source. And because it's published in what we call an open standard, virtually any application can understand and read the information published. You can read and understand the format, which means there's no vendor lock-in. So just quickly, you have in these 5 stars of linked data, as they're called, you can have information stored in a document format which is readable, such as PDF, which is more or less where most of our specifications are stored in today, in a form which is humanly readable and accessible via computer programs, but not computer interpretable, or there's no sense of logic in the information itself. You can possibly structure it in a particular way, such as in tables like an Excel program. However, not all applications can read what is stored in or can't read an Excel format, basically, and would still need you require extra information in order to interpret it. Next step would be to use an open format, such as in this case the CSV file, which more applications can read, unlike an Excel file in particular. You can also add more meaning, make your structure more explicit by using URIs in a format such as RDF. And by publishing it in a linked data format, you can suddenly access or have your information be accessed by various other publications, creating sort of a super publication altogether. Now let me try and give you some examples as to why you might want to store your information in an information model in a specification library. So say we've modeled the example I gave earlier, and we've published this in a linked data platform. Then we have our user from their computer who has access to this particular publication. Now, of course, the end user won't literally ask questions, but the end user can ask the dataset in our publication, particularly what they call queries, to make it possible to find, which makes it possible to find explicit set of information published in this information model format, right? So if he wants to know what specifications apply to his airplane, well, he can then find the 2 results that he needs. If he wants to know, for example, documents which contain specifications on takeoff speeds, for example, he can find these because they've been linked from the specification about takeoff speeds, or takeoff speeds specifically. Are there particular functions that the airplane should fulfill? Well, yes, we can find that this way in our information model as well. Whereas before, right, if we don't publish it in an information model, we'd have to scroll down on text-based documents and read bit by bit to find information, the information that we need. And even then, even if we use particular clever options, we might not necessarily find the information we need, right? Perhaps again, with this issue with regards to synonyms or terms which might be similar but not entirely, if the different terms are used within a set of documents, you might not be able to find what you need, whereas in information structure, you could, for example, say that an airplane has a cinnamon plane or is a subtype of aircraft, which makes it a lot easier to find the information that you need. Also, if you were to make your information more explicit, so even here, and with the examples I'll show later on as well, the requirements or specifications themselves are still text-based, but say you were to extract this even further and add more logic to the structure of your information model, you then necessarily have to sit behind your computer and ask the questions directly yourself. You could, for example, allow means of artificial intelligence or other forms of logic to do automated verifications or validations on your data set automatically, right? So that you don't have to, which is a step further than extracting the information in the model and then still perhaps having to interpret it later on in an application. Although it can be read by the application, you can now do it the other way around and have it verified or validated. Of course, this requires to make your information model even more explicit than we've given here in this example. Also, I mentioned something about versioning earlier on. And in case of publishing your information in datasets in linked data, there's also still versioning is still a task which has to be done. So you can have different datasets which can be updated for whatever reason, and there's roughly the same reasons as you would update a text document, for example. So each publication still deals with a version. However, you can sort of have your application still linked to these various versions and be able to interpret or understand the information at hand without having to deal with what the changes are necessarily, or have to search what the changes are and manually through a text-based document. Why is this? Well, our information that we extract from our publications, they have their own identifier, basically a web address, or for the more information sensitive people amongst you, their own URI or identifier, right? So instead of having to look for something similar as the takeoff speeds in every single publication, we can recognize it because it still has the same identifier. So it's still the same information, even though things might have, was still the same data nugget, so to speak, even though changes have been made within the publication. Now, this example is where the publication or the versioning is less explicit, but you can also make it more explicit by stating that, well, the information that we use in this particular application or within this particular project is specifically from this one publication, as you can see in the URI or in the web address. And if there's a different version, you can see this explicit as well, which means you can also trace where your versioned information comes from originally. You can still trace the source of your extracted information, unlike if you've extracted information from a document, typed it in an Excel file and loaded up into an application, then you more or less lose the explicitness of where you've extracted the information from, without having to do that manually every time again if there were to be a new version. Also, another benefit of using information models in terms of versioning is we can also, the versioning itself is also information. So we can also model this out if we want to. So you can imagine that we can model out the change logs between the publications, making it more explicit for our users or for our librarians, so to speak, as to what the changes are and what the original content used to be, as well as perhaps explanations with regards to this information. You could imagine that you could also model out, for example, comments or explanations as to why changes have been made to a new version of that same information. So that was a quick introduction to specification libraries. Now let me give you, let me demonstrate how this works in our LACES environment. So, if I'm not mistaken, Oh, pull this down. Yes. You can now see our SPL, our specifications library workspace that I've already started. I've uploaded a particular document to this environment as PDF. So this is one way. I'm first going to show you one way of extracting or creating our information model for specifications, because lots of the information that we want is still stored originally in text-based documents. So it's now up to us to extract this information and turn it into an information model. So I have a particular document here. I've already made my life a bit easier by bookmarking a particular page, which if I click on it, I've now automatically gone to that particular page. Now, what we see here, of course, is text. Are various types of different set of specifications, which I can then select information from or text from. Once I've selected this, you can see that my right side of the screen has changed, and now I can I'm faced with two options. I can either create a new model entity. I can relate this information to an existing model entity. Now, let's say that I've selected here this bit of text to be a specification. I can click on it, and I can, if I want to, change the name of my particular specification. So this one was about, let's see, parameters. So let me just call specification critical parameters. And here below, I can specify what type of specification it is. So I've already created beforehand 3 different types of specifications, one being a specification, a requirement, or a norm. For the simplicity, I'll just select that this is indeed a specification of the type specification. I can click Add, which then I've now created an information entity, which is this particular specification, where I can see where it's extracted from. So if I were to scroll down, I can say where did this information come from? Then the bit of text is highlighted again, and the page returns to where it originated from. Now, if I want to edit this, for example, I can also say, well, this is the text that I extracted, and for my sakes and purposes, I don't want this reference to this other text to be there. So then I simply delete it, and I can update it. And once I've done this, as you can see now, I can see what the previous version of my text is. So instantly I have a history of my specification text or specification information. Another thing, now that I've done this, is down below here, I could, for example, add more information in the sense of relating it to other information bits. So in this particular case, I could, for example, relate it to a subject, for example, plane, which I've already created beforehand. I can add this now, and now plane is related, or this particular specification is related to a subject plane. So if I go to plane, I can see that it's related to, in this case, 2 specifications. Now, how do I create something as a plane, which is a physical object? Well, say I look at my text again, and I believe that right here I have the term aeroplanes. Right, again, I can select this. Here I can state that it is a new entity. In this case, I can say, well, this particular text refers to an object. I can then also relate this object to another specification, for example. So I can go through the specifications I've already extracted and say, well, now this entity is related to this specification. I could also say that, well, that's all fine and well, but here I have the singular term aeroplane, whereas this was aeroplanes, right? So I could also say, well, this is related to this same object here, or sorry, aeroplanes was the case. So if you extract it, and now my object aeroplanes has references to 2 bits of text in the document, which means that now I know that the document, the information in the document here in two different places refers to the same entity, being an aeroplane in this case. Another thing is I could, for example, add comments. So I can, as a librarian, I could say, well, this has to be in singular form. Add the comment, and now I've added a comment to my entity. I can also see the history of this particular aeroplane if I want to. So again, I have a track of history, what I'm doing to my particular information object. Now, what I've done now, very basic, is just extract a specification and a physical object. If I were to create something else, approaches and landings or automatic landings, you can imagine that I can do this over and over again for any of these types of entities. So I can make explicit to my information model that these things in the text are said objects here. I can also click here to my model overview. So I was in the sources overview first, and I can now go to the model overview, where I can have trees of all the specifications, objects, and what have you in my model. Now, I don't necessarily need to have to extract information from the text if I need to. I can also just add, in this case, a new specification with regarding to, what was it again, take off speeds, for example, and create new information that way. So I don't necessarily have to be dependent on my text-based documents, which I want to get rid of because they're inconsistent or can lead to errors in interpretation mistakes. I want to go to my information model. I can also approach it from this end. Now, before I move to a more comprehensive or a larger example, I also want to show this option here. So as I mentioned before, this is still a lot of manual work and can take up time, but I also can use, for example, in our specification library, this analyze function, which will then scan the document and search for what it thinks can be specifications if I want them. So now it's already found 7,275 suggestions for specifications in this document. It's already highlighted something, and I can simply go, well, this is a specification. Thank you very much. Add it. And now let's go to the next one, and so on and so forth, increasing the speed that I can go through my particular document. Now, say that I've done this for a while, then I can end up with a document such as this one. Or not a document, sorry, a workspace such as this one. Here, there are two different documents uploaded to the specification library. So every specification library dataset doesn't have to be dependent on a single document. You can add various documents as you like and extract things or relate these extracted things from different information in different documents. And as you can see in this particular example, a lot more has already been extracted. So if I go to my model overview here, for example, amongst these specifications, of which there are different types. In this example, there are more specifications. I can group these informations if I want to, but what I want to see now is a table overview. If I don't want information simply about one type of information subject in a tree structure, I can also relate to a table overview where I can, for example, see all my specifications in this particular example, all the subjects they have, if they have verifications already defined to them, phases defined, organizations, etc. So if I go to my subject list here, I can also sort and filter if I want to what different topics I'm looking for. So if I'm looking in my workspace, in this case, for all specifications related to, for example, flying, I could use my table overview to achieve this. Now, as I've also mentioned that once published, you can publish or link, sorry, you can link your information to other linked data publications. So for example, here I have another object type library about aircraft, and I have an entity here of cockpit, which is related to specific specifications from the previous environment that I just showed you, which each has their own unique URI referring back to a particular publication in the SPL, in the specifications library. Now, say that in a more applicable sense, all of this is published, and I want to use it in an application. So, for example, we can use Relatix, something many firms use for their verification management storage on projects. So if I were to, for example, go to specifications, and I'm interested in extracting or want to use specifications that I've published in one of my SPLs, then, for example, with this add-on, I can then, for example, select, in this case, general, and import the specification, after which it's then placed here with the text already in place, and it refers to, so this is this URI, this web address I mentioned earlier. I know from where this specification originates from in terms of publications. And I have the text here. Now this is simply getting specifications published into your application, right? Not necessarily too interesting, although I do have extra information here as well that it also got from the library. Say that I want to approach this from my physical objects, from my OTL overview. So this is similar to what I had shown in the previous webinar on object type libraries. Say I'm interested in my cockpit. I get the cockpit from my OTL onto my project workspace. I now, because things are linked, it now looks from the entity in the OTL. It now looks to whatever is linked to this in the publication, to the SPL publication. And I can now, for example, select these two specifications that I want to use on my project. And now, in just a few clicks, I've imported a physical object and the relevant specifications from the published specification library. So I can now start my project altogether. Of course, in this simple demo, I've done this manually step by step. You can imagine that if you create the correct query, for example, this can all go automatically in one go. And now I'm only focused on objects and their specifications, but of course, all the relevant information related to these entities, both in the object type library and the specification library, can also be queried in one go. For example, all the various phases and verification methods linked to these specifications, for example, I could also extract those, or import those directly into my application if needed, because it's all machine readable, interpretable in an open standard in our publication. This was just a quick demo of the SPL in action. Of course, there's a lot more to talk about with regards to the laces and our specification library. But we're coming to the end of the webinar, so I have to go to our closing comments. So the gist of this entire webinar is that now, with regards to specifications management, if you are an owner of norms or standards, for example, the publishing of your information in documents in text-based form can be rather difficult and strenuous. But then again, also for the end user who has to apply this information and interpret the information, this can also be quite a hassle. You can also imagine that if you are not an owner of standards or norms, etc., but you can have, for example, your own internal specifications to which you have to apply to, such as the quality management system. This information can be has to be reused every time and time again on your different projects, and when you have to do this text-based, it can be quite a hassle filled with errors and risks. So we say, don't do this anymore. Instead, take an information model approach, where you can then specifically query the information that you need which is relevant to your particular use case, and where there's also less chance of misinterpreting the information, be it the specific information chunks stored in the text originally, or be it when using the same information across different applications or between different parties, so that then it's all computer interpretable and there's no discussion about interpretations, etc. So, other closing comments. So if you feel inspired for the using specification libraries or publishing your standards or requirements that you have to use over and over in linked data format, well, contact us. We have the software available to make this happen. We have consultancy at the ready to help you either implement these software and applications, or to implement the information that you need into your information models, as well as we provide our clients with trainings to do this work themselves. You can also, if you want, contact us after the end of this webinar to receive a trial period for LACES. This is also applicable for the object type library, but now also for the specifications library. So you can get more in-depth information about our tool, how to apply this for your particular use cases, and well, how to extract information in the best way in linked data. That was it for me today. Thank you for joining us. I hope you all have a good day and a fine weekend. Stay safe, stay healthy, and we hope to hear from you again later. Thank you very much.